Good morning, guys. Today we're going to begin our unit on how to collect data. We worked the last few units on how to analyze data, whether we're graphing it, whether we're doing calculations and summary statistics with it. Now what we're going to do is look at ways to actually generate that data. So our first section here is called sampling and surveys. So it's how do we physically get a group of individuals to collect data from, or collect data about, and then how do we kind of interact or engage those individuals. So that's what we're looking at with surveys. So here's kind of our setup for this lesson. What is the opinion of Riverdale students towards the current administration? So this is a piece of information that we want to know, and we want to figure out what's the best way we can go about answering that question. So just a couple of vocab things to start. A lot of vocab is what this section, this whole unit is about. First thing is population. When we say population, what do we mean for the population? So the population is just a group of individuals that we want to learn about. So in our scenario, what's the group of individuals that we want to learn about? Well, we want to learn about all Riverdale students. So that would be our population for this question, would be all Riverdale students. Now, there are a couple of different ways we can go about answering that question or learning about this group of students. One, we could conduct a census. That's a word that should kind of be familiar. We should all, I think, would know what a census is, but we especially should know kind of what's going on right now. A census is just where you interview every single individual in the population, or we collect data from every individual in the population. So in our scenario, we would ask every Riverdale student. Well, that seems like the best thing to do, right? Because we would know exactly the opinion of Riverdale students if we talk to every single Riverdale student. But as we know, nationally, when we're trying to conduct a census, it only happens once every 10 years. Well, it's just because logistically it's very difficult to get in touch with every single individual in the population, even at a high school. It's hard to get in touch with everybody. You know, right now we have in-person learners and distance learners, so how do we get in touch with all of them? Maybe the days that we have to be able to go out and do some surveying. There are certain students that are here or not here for various reasons. So just being able to talk to every individual in the population can be problematic. So a census, while it gives us the best idea, it's logistically not very reasonable a lot of times. So that's where we're going to move to what we do most of the time, which is work with samples. So a sample is just when we collect data from a small portion, or just a portion of the population. It could be small, it could be large. So for what we're doing, we wouldn't need to talk to every Riverdale student. We just need to talk to some Riverdale students. So Riverdale is sitting about 2,000-ish students at the moment. So I think we could get away with saying 100 students would give us a pretty good idea. If we get the right 100 students, we could get a pretty good idea of what all Riverdale students are thinking. So we could just say, we could ask a group of 100 Riverdale students. So we don't need to talk to everybody. If we do a good job of getting those 100 students, we can actually learn a lot about the population. And that brings us to our last word here, which is inference. All right, so inference is a word we talked about very, very early in the year. We've done a little bit of inference at this point, but we're going to kind of focus on, at the end of this unit, what kind of inference can we draw? What is the scope of the inference based on how we designed our studies? And inference is nothing more than drawing conclusions. So inference is where we draw conclusions about a population based on data gathered from a sample. So what did this small group tell us about the whole group, the group as a whole? All right, so most of this section we're going to be talking about sampling. How do we get those individuals? How do we make sure we get a good group of 100 Riverdale students so we can draw good conclusions or make good inferences? Well, let's first talk about things we don't want to do. Okay, so let's identify some ideas of poor samples. Now, what do we mean when we say a poor sample? Well, as I said, if we get the right 100 students, we can learn a lot about the population. So a poor sample would not be the right 100 students. So poor samples are samples that are not necessarily representative. And this is something we're going to talk about a lot, representative samples. A representative, so if we think of representatives, they represent us, so they represent the population. So a representative sample is a sample that looks like the population. So a non-representative sample does not necessarily look like the population. So these are some poor sampling techniques that we're going to talk about because they may produce a representative sample, but they're very likely to not produce a representative sample either. So they wouldn't give us a good picture. We wouldn't be able to draw good conclusions about our population. And the reason they're not necessarily representative is because they have some inherent bias in it. So what do we mean when we say bias? So a lot of people, when they hear the word bias, they think of just their common experience with biases means you don't like one group or your opinion's skewed one way or you favor another group, those types of things. Well, it's sort of that same idea in statistics. But bias is not so positive and negative. It's really, did we look like the population or did we not look like the population? Are we over or underestimating what's going on in the population? That's what we mean with bias. So with bias, you want to just think of a sample that consistently, or a study that consistently overestimates or underestimates. Overestimates or underestimates a population parameter. Population parameter. Parameter is just a fancy word for characteristic of the population. So you'll hear me use that word a lot going forward, but a parameter is just some characteristic, maybe the average of something in the population, or a proportion within the population, or the standard deviation of the population. So it's some characteristic of the population. So we consistently overestimate or underestimate a population parameter, and it's by design. Okay? And when I say by design, it may be intentional, maybe unintentional. Okay? Doesn't necessarily have to be nefarious. So it could be intentional or unintentional. Sometimes it's just necessary because maybe the study is, or what we're curious about is just something where we can't get a good sample. So there's just going to be some bias. As long as we're acknowledging that, maybe we can kind of at least draw some limited conclusions about what we want. So consistently overestimates or underestimates a population parameter by design. So a lot of times like to think bias is like stereotypes, right? So you see a group and maybe you make an observation about what's going on with that group and you generalize it to the whole group. Well, that could be an example of bias if your group that you made that observation in does not necessarily is not representative of the whole group. Okay, so you're overestimating that characteristic in that population or underestimating that characteristic in the population. So that's what we're talking about when we say bias. It can be intentional, it can be unintentional, but it's all based off the way you collected your data. So because we generated a group of individuals that may not necessarily look like what's going on in our population. What we learn from that sample doesn't necessarily represent it, overestimates or underestimates what's really going on in that population. So again, it's like what happens when people do stereotyping and things, but it's all about because of the group we looked at, or the subset of the population that we made our observations from. All right. So that's what we're talking about with bias. Now, these first two samples are inherently going to have the potential for bias. They may not. We could do these and still get a nice representative sample, but it's just luck of the draw, chance if that happens. So because we're not putting a lot of controls on it, we usually assume that there's bias involved. Remember, overestimating or underestimation from these two groups. All right, so the first type of sample we've got is what's called a convenience sample. I think these are pretty self-explanatory. What do we mean by a convenient sample? Well, it's a group that's convenient. So a group that's easy to collect data from. So a group that is easy being a relative word, to collect data from. Okay, they may look like our population, may not look like our population, but we're just saying we're going to get a group. So if we're saying we got our 100 student Riverdale students, that's our goal. We want a sample of 100 Riverdale students. A convenience sample could be if I just walked in and found the first 100 people to walk in the school building on any given day. Right? That would be convenient. I just stand at the front door, and then as people start walking in, I ask them my question. What's your opinion of our current administration at Riverdale? So that would be very convenient to do. So we could ask the first 100 students to get to school. All right, now, is their opinion necessarily going to be representative of all of Riverdale? Well, that group probably is not representative, so their opinions may also not be represented. Because who gets to school early? You have probably kids that ride the bus get to school early, so you're probably looking at younger students. Obviously, right now it's an in-person student, even though because distance learners wouldn't even show up to school, that type of thing, or physically come to school. So if we're looking at those 100 students, you're most likely just getting young in-person students. Well, they probably have a very different opinion than maybe older students, who have seen multiple administrations at the school, or distance students who are encountering the administration in a different manner than the in-person students. So their opinion would not accurately, we don't believe, would accurately estimate what's going on in the population. So that's convenience sample. That's why we want to stay away from convenience samples. Voluntary response sample. So voluntary response, again, I think that one's self-explanatory. People are choosing to respond. But the key is that they're choosing to respond to an open invitation. Everybody had the chance to respond, okay? But these people chose to respond. So voluntary response sample is a group who chooses to respond to an open invitation. And we kind of do these all the time. We're actually kind of in the middle of one right now. That's really what an election is, isn't it? Because when you have an election, when you have a voluntary election, not every single person participates. So when you're seeing the results of the election, you're not getting a census. You're not getting an account of what everybody wanted. You're getting an account of what a sample of the population wanted. So whenever we do school elections, whenever we do federal, state elections, anything like that, whenever we vote on something and it's a voluntary vote, you're really just getting a voluntary response sample. So we could easily do one of these. We could just send an email to every single student in the school, right? And say, what's your opinion? All right, so that they would then volunteer to respond. It's an open invitation. Anybody can participate, but those individual students will volunteer if they want to respond. So that's what we could do. We could send email a survey, send a survey to every student's email. And everybody that responded, that would be our sample. Yeah, maybe we would get 100 back, I hope so. So are we really learning about the population though when we do a voluntary response sample? So think of when we have homecoming elections. Think of when we have student body, officer election. Think when we have presidential election. Are we really learning about everybody in the population? No, what we're really learning about is just the people that are highly motivated to vote. So maybe if it's homecoming and there's a band person up for homecoming queen, the band kids are really going to go vote because they want that band person to become homecoming queen. Okay? Or if we're doing a student body thing and we have a basketball player who's running for student body president, so then maybe all the athletes are going to be motivated to vote so that we have a basketball player as student body president. Okay? So that's how you want to go through and think of voluntary response. Usually, you only learn about the highly motivated. Or highly opinionated. Usually learn about the strongly opinionated. We may be seeing that a lot in our upcoming election because you've got the group that really, really supports one candidate and then the other group that really, really opposes that candidate. And so you're going to really get a battle of those really strong opinions where there's people that really don't care either way. Are they willing to go through those steps to go out and vote? Or are they just going to stay home and just say whatever happens, happens? So voluntary response, usually we're only learning about those people that are strongly opinionated. So we're not really always getting an accurate estimate of what's going on within the population. And now let's talk about some representative samples. Okay, so we've talked about non-representative or poor samples. Let's look at representative samples. As before, represent means it is going to show or display what's going on for the bigger group, right? So a representative sample is a sample who mimics. A sample that mimics the key characteristics or instead of key, you could say the relevant characteristics. Okay? Mimics the key characteristics of the population for a certain question. So whatever it is we're trying to learn about our population, whatever those characteristics are that might influence how a person responds. So in our question, we want to know the opinion of Riverdale students towards the current administration. Maybe a student's grade level affects that. Maybe a student's gender affects that, their opinion. Maybe a student's, I don't know whether they're in-person or distance learner affects that. Maybe a student's extracurricular activity participation affects it. All these things that might play a role in how a student views the administration. In a representative sample, those characteristics show up in the sample the same way they show up in the population. So if we thought gender played a role, maybe 50% of our school is one gender, then 50% of the population or sample should be that gender. If we think that sports participation or extracurricular participation plays a role in that opinion, whatever the percentage of students that participate in those extracurricular activities, maybe a representative sample, that same percentage of students in the sample is, doing the extracurricular activities. That's what we mean by a representative sample. Those characteristics that show up in the population that might influence how we answer should show up at the same rates or similar rates in the sample. So there are a couple ways. There's really three different ways that we go about trying to get a representative sample. And you can actually do any combination of these, and you can call it multi-stage sampling and things like that. But we kind of look at them as one-offs right now. So we have a simple random sample, a stratified random sample, and a cluster sample. So let's just start with simple random sample. You're going to say abbreviated SRS. So random, I think that's a number or a word that we're kind of familiar with. Random just means anything can happen, right? So simple random means we're going to take it kind of one individual at a time. One individual at a time. So got a few traits in a simple random sample. First off, any group of size n, any number, you can have a group of any size, can be chosen from the population. So for us, we're trying to get 100 students, so we could get literally any 100 students is possible for a simple random sample. Okay? Any group of 100 students is possible if we do a simple random sample. Now, that usually then means that choosing one individual does not affect the probability of another individual. So the fact that I selected Steve does not affect Emily's chances of being selected for this sample. So that's what we're talking about when we do simple random sample. So a lot of people, I'll ask the question like, so give me an idea of how we could get 100 students. And people are like, okay, you could go grab one person from each classroom in the school. Or grab a random person from each classroom in the school. Well, that wouldn't necessarily be simple random. Okay? Other people are like, okay, well, what if you just grab every other person to walk in the front door, right? So every 5th person or every 10th person to walk in the front door. That's like a systematic type thing. Well, that also wouldn't be random. And the reason is because once I pick that first person, the next 9 people are now eliminated. So that one person being chosen affected the probability of those other people being chosen. Same as if I went to one person in each classroom, that one person being chosen now just eliminated every single other person in that classroom. So when we say a simple random sample, I truly could do 100 students and they all come from 4 classrooms. The possibility is there for that to happen. Now, I probably wouldn't like for that to happen, but that's a possibility of happening. I could do 100 people and they just happen to be the first 100 people to physically show up to school that day. So those are things possible with a simple random sample. Now, the reason that we're okay with that possibility is because it's very, very tiny that it happens. What is more likely to happen is the key characteristics or the key traits of the population should be randomly distributed throughout the sample. Should be. So if I do a random sample and we say we have 55% of our school's female, 45% is male, and we think that may play a role. In my random sample, I don't have any control over how many males and females, but my random sample should come out to be about 45 male, or sorry, 45 male, 55 female. Now, it's very possible that I could get a random sample that's 80 males and 20 females, because any group of 100 is possible. But our truly random samples, they should, for all those key characteristics, show up pretty consistently. Now, this is going to go into what we're going to talk much later in the year. Because we don't know what our characteristics of our population exactly look like, how they relate to the sample, and we know that anything is possible in the sample, we have these things called margin of error and confidence levels and confidence intervals that kind of give us that wiggle room to say, okay, this is what my sample said. Now let's say, okay, maybe my sample doesn't look exactly like the population, can I get a range or an estimate of what's going on truly in the population? And we do see those things when we see polls and surveys that are done, like the presidential polls, and you see plus or minus 4%. That's because they know their sample is not very likely to look exactly like the population. So that plus or minus 4%, that's the wiggle room that they put in there. Like, okay, it's going to be close to these numbers though, because we feel like we've done a good job of selecting our sample. So that's what we mean by it. They should be randomly distributed throughout the sample, but in random, anything is possible. All right. So kind of a visual for what we mean when we have a random sample. So let's just say that this is my population of Riverdale High School. So that's RHS. That green circle right there. In a random sample, I could get anybody in the group. So I could get these students here could have randomly been chosen. So really anybody in the group is possible. So I could get those 100 dots right there, those 100 students from Riverdale High School. All right, now how do we get random samples? We have quite a few little tools that we've got. I could do slips of paper. Right, I could write every single student's name on a slip of paper, put them in a hat, and draw out 100. That should be random if I kind of make sure they're all the same size and dimensions, and I mix them thoroughly. I could do flip a coin. Right, I could have each student walk up to me, flip a coin. Yes, you're in. No, you're not. I could roll a dice. So if we rolled dice, it could be the same thing. I could give every single student, I don't know, a number 1 through 6, and then I could just roll and like, okay, everybody that had a 1, you're in. Or I could roll a 2. Everybody that had a 2, you're out. So I could just, something along those lines where I could just roll a number from dice. I could spin a bottle. Not like spin the bottle, but like do a spinner of some type. So I could put the entire group, entire population in a circle, turn some kind of spinner, whoever it points to, that person is now in my sample. Close off the circle, spin it again, do the same thing. That next person's in my sample. Because see how choosing one person didn't affect the people next to them or anybody else in the circle. Everybody still has a chance to be chosen. So these are all situations that could give us a chance to be chosen. Now there are two more technical ways that we're going to look at, and that's a table of random digits. So random digits table. And we have a random number generator. These are the ways that we're more likely to get our random samples. Slips of paper is usually a pretty decent one, but if we're wanting kind of a quick way to do it, I don't want to have to be able to write everybody's name down. Random digits table and random number generator are probably the two best technical ways we have of getting a random sample. All right, so let's look at a couple of those tools for randomization. First is the table of random digits. We've got one in the back of the textbook, but you can find them all over the place. This is what they look like. They're literally just a table of random digits, just rows and rows and columns of numbers. The spaces don't mean anything. The colors don't mean anything. It's just meant to help read it a little better. This first right here is your row count. So this is row 112, this is row 116, and so on. These are the actual digits. So how would we use a table of random digits? First, you'd assign all the students in the school a number. Next, we would just choose a random row to start on, and we would divide all of it into 4-digit numbers. 4-digit numbers because we have around 1,900 students in the school, so we want chunks of 4 numbers. Then you just continue along a row, and if you get to the end of one row, go to the next row until you've got 100 unique sets of 4-digit numbers. And then you go and interview the students who correspond to those numbers. So let's look at an example. So if I say I started on row 110, and I just divide them into all these chunks of 4. So there's 4 digits, 4 digits, 4 digits, 4 digits, 4 digits. And I got to the end of this row, I went to the next row. So just divide them all up. And we're looking for numbers starting here at the beginning between 0, 1, 0001 and 1900. So as we read along, you find all these little, there's 676, there's 41, 404, 1197. All these other ones are numbers that weren't in that interval, so we don't worry about it. 640, 1776, 381, 220, 215, 1445. Notice we have another 1776 here, so we need unique digits. I don't want to interview students 1776 twice, so we wouldn't count that. And we would just keep going through. This is about 25 numbers. We would keep going until we got 100 students, 100 unique students, and we would go interview them. So that's how table of random digits works. Random row, and just start reading across in increments of whatever your digits are that you have to work with. Random number generator is a calculator function. So first, again, we're going to assign all the students a number, 1 to 1900. Notice here we don't have to have them be the same number of digits because we're not doing random digits on the table. We're going to do a random number generator. So then on the graphing calculator, we're going to go to the math menu, probability menu, and then option 5 is random integer. You just put what your numbers are, 1 to 1900, and then you put what size you want. So I could choose them 1 at a time, I could choose them 10 at a time, I could choose them 100 at a time. Remember, you want unique numbers, so we'll talk and look at some different ways we can key these in class to kind of eliminate repeats and stuff like that. So once we've got our 100 unique numbers, we then go interview those students. So let's go through and actually look at that calculator function. So let's pull up our graphing calculator here. So we can see the math button over here on the left, probability menu, and then there it is, option 5, random integer, which is what we want. All right, so we want random integers between 1 and 1900. So our lower boundary is 1, upper boundary is 1900, and n is how big of a chunk you want. So as I said before, I could grab them just one at a time. Just hit enter, 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 and it just keeps giving me random numbers, and I keep just writing them down. Each one of these represents a different student. And if I got a repeat student, I just throw that one out until I get my 100. We'll look at different ways to throw out the repeat students. So if we were to change this to a 10, now it's going to give me a list of 10 of them. So there they are in chunks of 10, or I could even go grab all 100 at one time. And there you can see there's going to be a list of 100 random digits between 1 and 1900. Right, so these are two little tools that we've got to be able to generate some random numbers, no matter how I need to use randomness. All right, so that's it for part 1 on sampling and surveys. And in the part 2 video, we will talk about a couple different ways we can do some sampling with a little bit more control in stratified and cluster samples, and we will talk about some issues that can arise with data collection while we're doing some surveying. So that's it, and I will see you guys in class tomorrow.